All right, homework 34. Now we are going to be working with vectors. Vector is just a math quantity that has both a size and a direction. Usually they represent it with an arrow. So if I think about it, if I had a vector like on this one that was 3, 3, means it went 3 here and 3 here, and it would be shooting off like this. And so, in order to find the size or the magnitude of that vector, what I'm really doing is just using my Pythagorean theorem because I have a right triangle there. We know that a squared plus b squared equals c squared. So if I solve that, c squared equals a squared plus b squared. So c is equal to the square root of a squared plus b squared. So same thing with your magnitude of your vector. Symbol for magnitude of a vector, they're going to do something like this. Magnitude of the vector is equal to the square root of a squared plus b squared. So in this case, our vector went 3, 3. So I'm going to have 3 squared plus 3 squared. 9 plus 9 gives me the square root of 18. And then, of course, since I'm working with square roots, I would want to simplify that. 18 factors into 9 times 2. So 3 square root of 2 would be the magnitude or the size of that vector. So if we look at the next one, we want to find the magnitude of our vector. This time, whoops, there goes my board again. 2, it did stay on number 2. This time my vector goes 4, negative 4, so it's going this way. But again, we're finding the magnitude of our vector, and so we're just going to do the square root of a squared plus b squared. So I would have 16 plus 16, which gives me 32. 32, we would say, is the square root of 16 times 2. So 4 square root of 2 would be the magnitude or the size of your vector. 4 square root of 2. Number 3, this one is going negative 6, negative 4. So negative 6, negative 4 means it's going down in this direction. So again, the magnitude of my vector, a squared plus b squared, I'm writing the b, negative 4 squared. And so negative 6 squared would be 36, negative 4 squared would be 16. If I add those together, I get 52. 52 is 4 times 13. And so I would have 2 square root of 13 for the magnitude or the size of my vector. So a vector is a quantity that has both a size and a direction. Here we're doing the direction, negative 6, negative 4, to find the size of it. We're actually just using the Pythagorean theorem, but they're going to solve it. And so square root of a squared plus b squared, and simplifying, we can find the size of our vector or the magnitude of our vector. 4, 5, and 6 are having us find the unit vector that's in the same direction of 6, 7. A unit vector is one that has a magnitude of 1. So in order to find the unit vector, first of all, we're going to find the magnitude of the vector that we have. So the magnitude of our vector, again, is the square root of a squared plus b squared. So we would have the square root of 6 squared plus 7 squared. 36 plus 49. If I add those together, it looks like here I would have the square root of 85. Square root of 85 would be the magnitude of our vector. To do the unit vector then, basically all you're going to do is use these for the numerator, this for the denominator. So I would have 6 over the square root of 85 and 7 over the square root of 85 for my unit vector. Just checking that out, we said that if it is a true unit vector, that the magnitude of our vector would be equal to 1. So I would say, okay, if I did 6 over the square root of 85 squared plus 7 over the square root of 85 squared, I should get an answer of 1. 6 squared is 36. When I square the square root of 85, it just stays 85. 7 squared is 49. Again, when I square the square root of 85, I get 85. 36 85ths plus 49 85ths would be 85 85ths, which is 1. And the square root of 1 is still 1. So yes, this indeed is a unit vector. When I find the magnitude, I get an answer of 1. But basically all you do is find the magnitude of your original vector and then use these in the numerator, the magnitude in the denominator, and you then have a unit vector that's going in the same direction as that, but has a magnitude of 1. So number 5, if I want to find my unit vector, again, I'm first going to find the magnitude of my vector. So the square root of negative 3 squared plus 1 squared would give me 9 plus 1, square root of 10. So my unit vector is going to be negative 3 over the square root of 10 and 1 over the square root of 10. And that vector should have a magnitude of 1 if you wanted to check it out. Number 6, same kind of thing. Find the unit vector in the direction of negative 4, negative 7. So finding the magnitude of our original vector, negative 4 squared plus negative 7 squared would give me 16 plus 49. If I add those together, it looks like I get the square root of 65. And so my unit vector is going to be negative 4 over the square root of 65 and negative 7 over the square root of 65. And there's my unit vector that's in the same direction as negative 4 and negative 7. Seven, 8, and 9, you're doing multiplication of a vector by a scalar using a geometric approach. You're going to do some construction. You're going to use this tool to move your vector to P, and then you're going to scale your vector using this tool and then moving it either forward to make it longer or backwards if it has to be negative. So we'll go over on Alex and use that tool, but just what I'm going to write here is some instructions. So you're going to move the end point of A to P. So you're going to grab this tool right here, grab that, just pull it over so that the end point on here ends up moving it just over to there. Then scale to 1.7. So I'm just going to use this tool. I'm going to grab this and make it longer so that it says 1.7 next to it, and that's all I'm going to end up doing. So if I go over to Alex, we said we were going to do, whoops, doesn't want me to write. That's okay. We said we were going to make this 1.7 instead of 1.6. So I know my arrow's going in a different direction, but just to give you an idea, again, it's going to erase that. Well, maybe I'll just do this one here. I'll just do this one here. I'm going to use this tool right here first to move it. So I'm going to grab this, and it doesn't want to cooperate, so I've got to use my mouse. So I got my hand tool. I'm going to grab that. I'm going to move the end point of A on top of P. I'm going to click in the gray box so you can see what I did. So I just picked up my vector, moved it so the end was on P. Then I'm going to use this tool right here with the two arrows. I'm going to make this one's going to be 1.6 instead of 1.0, so I'm going to make it longer. So I'm just going to grab the end and I'm just going to pull it until it says 1.6. Again, if I click in my gray box, that turns off my tool. So if I want to make it longer, I grab it. If I want to make it negative, I go in the opposite direction. Notice I went in the opposite direction. There I'm at negative 2.3. Positive, I make it longer or shorter, but it stays positive. If it's negative, I go in the opposite direction. Again, changes the sign to a negative. So 1.6a, which is the one that we had here, would look something like that. And that's all I'm going to do to that. So in number 8, again, first thing I do is move this over here. So it would be 1.0a, but the end is on top of p. Now this one I want to construct so that it's negative 1.9. So what I'm going to do is grab the end and I'm going to pull it backwards until I see negative 1.9a. So this won't show up. The end point will be on p and it'll go negative 1.9a. So just for fun, if I take the one that was over here, it was at 1.6. If I wanted it to be negative 1.9 again, I'm just going to grab the end, push it backwards until it says negative 1.9 instead of positive 1.6 is what it was at. So you just push it backwards until you get to the negative answer that you want. Number 8, or 9. Number 9, same kind of thing. I would start and move it up here. So I move it so the end was on there, pointing in the same direction, still says 1.0a. This time I want it to be negative 0.5a, so I grab this end, push it back this way until it was at negative 0.5, and so my end would be at p, this part would be gone. If I could draw straight, and it would look something like that when I was done. So move the end to this end point, use the scaling tool. If it's positive, pull the end forward. If it's negative, push it backward until you see the number that should show up there. (10, 11, and 12 are translating our vector. So if I think about it, if I have my vector, it has an initial point at 1, 4. So over 1, up 1, 2, 3, 4, there's my initial point. My end point is at 1, 2, 3, 1, 2, 3, 4, 5, 6. My terminal point or end point would be at 3, 6, and my vector would go like that. Now what they want you to do is translate it so the initial point is at the origin. So if my initial point is going to go to the origin, I'm going to move it back 1 and down 4, right? So it's just really the opposite of what these values are here, because if I was at 1, 4, I'd have to go back 1 and down 4 to get back to the origin. So if my terminal point is at 3, 6, and I go back 1 and down 4, I would then end up at 2, 2, right? If I go to the left 1 and down 1, 2, 3, 4, now my vector is going like that, and would be at 2, 2 if I could draw straight. And so my new terminal point there is at the point 2, 2. Number 11, same kind of thing. My vector has initial point at 2, negative 1. So 2 over down 1's my initial point. My terminal point is 5. 1, 2, 3, 4, 5. Negative 6. 1, 2, 3, 4, 5, 6. Somewhere down there. So my vector's going like this. I want to move it so that its initial point is back at the origin. So if it's going to go back to the origin, I'm going to go back 1, 2 places. So minus my 2. And then I have to go up 1. So plus my 1. Notice again, I'm just at the opposite of what I originally had my initial point at. I want to find where my new terminal point is. So if I go to the left 2 and up 1, I would be at 3, negative 5 for my new point. So if I was here, I went to the left 1, 2, and up 1. There's my new end point. Whoops, if I could draw straight, my new vector would be going like that and would be at 3, negative 5 if I put that down. Put that up a little high because my lines aren't very straight. But I would go back 2 and up 1. I'm really far off. There we go, that's a little closer. Back 2 and up 1, and I end up at my new spot. So, on this one, my vector has an initial point of -4, 2. So if it is at -4, 2, I would have to go +4 and down 2 to get back to the origin. So my terminal point was at -1, 5. I'm going to go +4 and down 2, and so now I'm going to be at 3, 3 for my new terminal point. So really, without drawing the graph, which you can do, you're just going to do the opposite of these. My initial point is at -4, +2. I'm going to add 4 and subtract 2 from my terminal point, and I can find the location of my new terminal point. 13, 14, and 15, we're doing vector addition and scalar multiplication. And just like you probably think would happen, if I am going to find 6s, I am going to take 6 times my vector, which is -6, 5. Which basically just means I'm going to take 6 times each of those values. So I am going to get -36, 30, and that's going to be my answer when I take 6 times s. If I'm going to do s plus t, s plus t means I'm going to take vector s, which is -6, 5. I'm going to add the components in the same spots of the 7 of the -9. So if I add those together, -6 plus 7 would give me 1. 5 minus 9 is -4. And so my new vector then is 1, -4. So 6 times s gave me -36, 30. S plus t gave me 1, -4. So I'm 14. Given the vector m is 9, -8, and n is -6, -2, find 5m. So 5m means I'm taking 5 times vector m, which is 9, -8. I would then end up at 45, -40. The second part of that wants us to find m minus n. So I'm going to take my m, which is 9, -8. I have to subtract the -6, -2. Now we know when we subtract, we end up adding the opposite. So I'm going to make that a positive and that a positive. And then just combining my terms, 9 plus 6 would give me 15. -8 plus 2 is -6. So when I subtract, I add the opposite, so I changed both those signs, and then I just combined my like terms. And number 15, same kind of thing here. I'm going to do 7a first, so 7 times my a vector means I'm going to take 7 times -6 and -1. So I would end up with -42, -7. And then I'm also going to do a plus b. So I'm going to take -6, -1. I'm going to add the 2, -4. Adding the numbers in the same spots. The -6 plus the 2 would be -4. -1 plus -4 would be -5. And that's all there is to those ones. 16, 17, and 18. Now we're going to find 4a minus 3b. So what we're going to do is take 4 times the a. We're going to take -3 times the b, because this would be 4a plus -3b. And then we're going to just add our two answers together. So 4a would mean 4 times my 3, negative 5, which would give me 12, negative 20. Negative 3 times my b, which is 2, 1, would give me negative 6, negative 3. I'm now going to add those two things together because I applied my negative when I took it times the negative 3 instead of just taking it times 3 and then having to subtract. So my answer, 12 minus 6 would give me 6. Negative 20 minus 3 would be negative 23. So now I have the vector 6, negative 23. The next one, we're going to take negative 2a plus 4b. So negative 2 times the a vector would be negative 2 times negative 6, 2, which gives me positive 12. Whoops, I'm going to put a plus sign there since I wrote. Positive 12, negative 4. If I take a positive 4 times my b, 4 times 5, 3 would give me the vector 20 and 12. And then again, I'm just going to always add those two answers together. So 12 plus 20 would be 32. Negative 4 plus 12 is a positive 8. So now my new vector is at 32, 8. And the last one, negative 5a plus 2b. So negative 5a, negative 5 times 6, 3 would give me negative 30 and negative 15. Positive 2b, 2 times negative 4, 1 then, would give me negative 8 and 2. Adding those two answers together, negative 30 minus 8 would be negative 38. Negative 15 plus 2 would be negative 13. And so now I have negative 38 and negative 13. And so that's just going to be my answer. That is the end of homework day 34. Nothing too terribly bad there, I don't think.